My battery died. Let's see where I was here. So we were just about to calculate the force of friction of this object. So to calculate force of friction, you need the coefficient and you need the normal force. So this is very important now. This is something you want to make a note of to yourself. Normal force does not have a formula. You can't calculate normal force. You can't look it up on a formula sheet. Normal force is not that kind of a force where you use a calculator to determine it. Normal force is the ground pushing up on the object to cancel out everything else in the up and down direction. So you need to look in the up and down direction and say, what else is there? There's a force of gravity. These have to cancel each other out. So they have to have the same value. So you're actually going to start here. The very first thing you want to do is you need to calculate the force of gravity. So this actually, in most questions, calculating the force of gravity becomes step number one. And I always say, when you're on the final exam or a final assessment in this class, if you're drawing a blank and you absolutely have no idea what to calculate in a question, always start with the force of gravity. It's usually the starting point anyway, and just by calculating force of gravity, things will start to click and maybe you'll know where to go next. So force of gravity has that very easy formula, m lowercase g. And I'm just going to kind of shift over to the left a little here because I don't want to conflict with this calculation we're going to do later. So the mass in this case is 50 kilograms. The G value, you never have to worry about that G value changing in this class, because every calculation we're going to do takes place near the surface of the Earth. So multiply those numbers together, 50 multiplied by 9.8, and you get 490 newtons. Okay, so that calculation is on its own. So now you make the connection and you say, well, if there's 490 newtons down, that's got to be canceled. Because if it's not canceled, there's actually going to be some acceleration in a downward direction. And of course there isn't. There's a surface underneath this mass. So you make the connection. This is step number 2. Without a formula, you make the connection that the normal force has to be 490 because they cancel each other out. That may sound like a frivolous step, but in grade 12, normal force isn't always going to have the same value as gravity. So it's going to get more complicated next year if you continue on in this subject. But for now, calculate the force of gravity and you can transfer that number to the normal force. Okay, so that's going to allow us to do step 3. We're going to calculate the force of friction now, which really is the only thing that we need to do this calculation. But to build up to getting the numbers to do force of friction, you have to work that out. So I'll put it down here. Step number 3, force of friction equals coefficient multiplied by the normal force. And I always write it like this. I write a little capital N. I just got used to that in university, but I'm telling you, you're eventually going to get that confused with net force. So I don't know if you want to do this every time. Write in the word normal. That's up to you. It's your own organization. But you have to remember not to confuse that with net force. Okay, so the coefficient of friction, we can actually look that up. So I'm going to flip back to this chart here. The question is steel on steel. That's here, steel on steel. And it's dry. There's a greasy version. So steel on steel dry. And let's assume that, I don't think it said in the question, it said a 50 kilogram piece of steel is being pushed across a dry steel surface with an applied force. So let's assume that that means it's starting from 0. And we'll use this one here. Steel on steel dry, the coefficient of friction from rest is 0.78. So let's use that. I'll go back to this question. Okay, so 0.78, no units. It's just a number, it's just a ratio, it's just a multiplier. And the normal force in this question, 490 newtons. So let's see what we get there. 490 multiplied by 0.78 is 382.2 newtons. Okay, so now going back to the diagram then, really then the only two forces that are to be considered in this question are you're pushing forward with 520 and there's friction coming off the back. Those two values, because everything really takes place in the left and right direction, those two arrows are what are going to create your net force. So you don't have to redraw a diagram, but I will just for the sake of it. This is really what's happening in this question now. You've got an arrow this way and an arrow that way, and overall there's going to be a net force. So this goes all the way back to kind of day one when we started forces. You're pushing forward with 520. There's 382.2 newtons coming off due to friction, and there's going to be an overall net force forward. I suppose I should label these. Applied force, friction. Okay, so remember, there is no formula sheet formula for net force. Net force is one of those formulas where you build it yourself. So just by looking at this diagram, net force is going to be whatever my applied force is minus friction, just based on what the arrows look like in that diagram. So I didn't get that off any kind of a formula sheet. But again, you need a three-step calculation format for every single thing you do in math and science. So let me do that on a calculator just so I don't mess up any numbers here. So that comes out to 137.8 newtons. So that is, I'm going to call this step number 4. That is the actual force now, finally, in this question, after you consider everything. And then to finish this question off, because remember, way back in the beginning, the actual question was this: what is the acceleration? Step number 5. And that's it. We're just going to fill in this last value. The net force is 137.8 newtons divided by 50. We finally, in the end, get an acceleration of 2.756 meters per second squared. At that point, the question could go anywhere. This could be an even longer question. It could go on beyond this point now and ask you to solve how long does it take to move 5 seconds, or sorry, how long does it take to move 5 meters? How far will it move if you apply this acceleration for 10 seconds? There are more calculations that can happen after this. So this is probably the longest calculation that you've seen so far in grade 11. And it's one of those calculations where if you saw this page in grade 9, you would have lost your mind. You would have looked at it and said, oh my gosh, I'm never going to be able to understand grade 11 work. It's so confusing. Don't worry. I mean, now that you see it step by step by step and you're actually here learning these steps, hopefully you can see how this all ties together into one rather beautiful calculation that isn't as stressful as it looks to somebody that doesn't know the work. You're going to feel exactly the same way if you look at university work today. It'll look like gibberish on the page, and you'll wonder how you're ever going to understand that work. But you'll get there step by step, and it'll make sense when you're there. Let's do one more example, example 2. And I'm going to have to move the camera over a little here. The sunlight is shifting on the desk. Let's do example 2. And then that'll end it off. Okay, a 20 kilogram rectangle made of rubber, so that might be important later on. I see a material there. 20 kilogram rectangle made of rubber is being forced forward across the surface of a road by an applied force of 400. So let me draw that on there. Applied force equals 400 newtons. The actual acceleration of the object, that's kind of weird. They don't usually give you acceleration in the beginning, but this one does. The actual acceleration is 17.5 meters per second squared. I don't know where to draw that on the diagram because it's not a force arrow. Maybe I'll put it up top here and I'll just make it kind of a squiggly line maybe, not to confuse it with any forces. But I don't want to forget that this was given. So 17.5 meters per second squared. And that's it. That's all they give you in this question. It says calculate the force of friction that the object must be experiencing. So guys, here's a perfect example of engineering again, because when you read a question, you don't necessarily know how to do it. I don't know how to do this question. Really, there's only 3 numbers given, and with those 3 numbers written on the diagram, I don't even see the connection here. Like, I don't know how these go together. Part A says, solve for the force of friction though. So, force of friction, there's only one formula for it. It's coefficient multiplied by normal force. Well, the problem in this question is it doesn't say what the road is made out of. And I'd like to assume that the road is probably asphalt and look up rubber on asphalt, but what if it isn't? So I'm a little bit worried about this. I don't want to do the question wrong. There are 2 different ways that you can solve for a force of friction. You can use the force of friction formula, no problem. But if that doesn't work, if you don't have enough givens to actually calculate force of friction using the formula, you can always think of force of friction as just an arrow on a diagram. Like, don't forget, go back to day 1 of forces when we first started. There were no names to these forces. They were just arrows. Force of friction is an arrow pointing to the left. There's an arrow pointing to the right of 400. When you subtract those from each other because they're in equal and opposite directions, you get the overall net force. And when you get the overall net force, you can solve for acceleration from that net force. But they already give us the acceleration, so I'm thinking there is a formula for net force, ma. It's not very often that you're given the acceleration in the beginning, but if you are, you could always calculate net force. Like, we have enough to calculate net force here. There's a mass of 20 kilograms and an acceleration of 17.5 meters per second squared. So run those 2 numbers, and yes, it comes out to 350, dead on. So here's an example of a situation where you don't need physics to solve for the force of friction. You can just look at the arrows. There's a 400 Newton push forward, some friction comes off of it, and it results in a net force of 350. We really should write a formula for that, but because the numbers are so easy, and this is just an example, I'm going to jump right to this. It's obvious from these numbers that the force of friction has to be 50. You're pushing forward with 400, but you're only actually succeeding in getting a net force forward of 350. So that's because 50 newtons of friction has come off. Well, step A does ask you to calculate force of friction, and I don't just want to write 50 as an answer, so let me do this. Net force forward is whatever the applied force is minus friction. Rearrange and solve, or I'll just put numbers in. My net force is 350. The applied force is a 400 Newton push. And rearrange that and solve for force of friction. Move things over the equal sign, etc., etc. You're going to get 400 minus 350 for a final answer in the end of 50 newtons. Okay. Now it wants you to solve for the coefficient of friction. So that's important. You don't look the coefficient up in this question. It's asking you to actually solve for it. There's only one way to solve for coefficient of friction, because there's only one formula in the course where you even see coefficient of friction, and that's inside the friction formula. So guys, if you're ever asked to solve for a coefficient of friction, this is the only way that you can do it. Rearrange this formula, and coefficient of friction is going to be the force of friction divided by the normal force. So we've got force of friction from part A. That's 50 newtons. We need the normal force, and be very, very careful here, because that is not the net force. It's really tricky in this question because we figured out the net force earlier and got 350. So I'd be very tempted to substitute 350 onto the bottom of that equation, but they're not the same force. This is the normal force. So remember what normal force is. That is the surface pushing up on the mass. Let me go back to the diagram here. Normal force is here. Normal force is the road pushing up on this 20 kilogram mass. And there's no formula for normal force. You can't flip to a formula sheet and calculate normal force. Normal force opposes everything in the up and down direction. And there's only one other thing in the up and down direction. There's a force of gravity. So, roundabout way, we have to calculate force of gravity. Wow, there's so many calculations on this page and it's becoming such a mess. Another reason why you have to number all your steps all the time. I'm going to do this. Off to the side here, I'm going to calculate the force of gravity. It equals mg. The mass in this question is 20 kilograms. G value is 9.8 meters per second squared, or newtons per kilogram if you like. Multiply those together, and the value comes out to 196. So if the force of gravity in the downward direction is 196, then the normal force has to cancel out with it, which means the normal force has to be 196. So to finish off this calculation for force of friction in step B, it's 50 newtons of friction divided by 196 newtons of normal force. The units cancel, which is the normal result, the usual result. Coefficients of friction are unitless. And you get a final answer of 0.255, no units, which feels very weird. And part C says, is the road made of concrete or asphalt? And is it dry or wet? So now you could take this value, because remember, it did mention in the question that the